In this video, we will be introducing summation notation. Let's look at some of the names of the parts. This I right here is the index of summation. And usually you'll see I, J, or K for the index. This 1 is the lower bound of summation. And it's the number that you start with. And the number up on top here is the upper bound of summation. And it's the number that you end with. So to evaluate this expression, our term is 2i. Notice it's 2 times I, and I is going to increment by 1 from the beginning number, this 1, all the way up to the ending number 4. So I'm going to take 2 times the first I value, which is 1, and add that to 2 times the second I value, which is just 1 plus 1, or 2, plus, and then 2 times the next I value, which is 3, plus, and then 2 times the next I value, which is 4. Now, as soon as your I value that you use is the same as the upper bound, then you stop. Notice on all of these I have 2 times the I value. So the I value goes from 1 to 2 to 3 to 4. After you've written it out, then you can go ahead and add these up. We have 2 plus 4 plus 6 plus 8. So this expression, the summation as I goes from 1 to 4 of 2i, is equal to 20. Let's look at another example. We will evaluate the summation as k goes from 4 to 6 of the expression 1 over k. So again, we're going to take this expression and substitute in our starting value of k, which is 4, so 1 over 4, and add to that same expression, but with our next value of k, so 1 over 5, plus our next value of k is 6, so 1 over 6. Now this value of k is the upper bound of our summation, so we're going to stop at that point and evaluate. 1/4 plus 1/5 plus 1/6 is equal to 37 over 60. Let's do another example. Let's evaluate the summation as a goes from 0 to 3 of 2 to the j power over j plus 1. Now in this example, we have two places where our j value will be substituted. So we'll start with j equaling 0. So I have 2 to the 0 power over 0 plus 1. Then add to that, my next value of j is 1. So 2 to the 1 over 1 plus 1. Notice that you put the second value of j into both spots. Plus 2 to the second power over 2 plus 1. Plus 2 to the third power over 3 plus 1. Now here the j is equal to 3 in both spots, and 3 is our upper bound of our summation. So we're going to stop at this point, and 2 to the 0 is 1 over 0 plus 1 is 1, and then 2 to the first power is 2, 1 plus 1 is 2, 2 to the second power is 4, 2 plus 1 is 3, and 2 to the third power is 8, 3 plus 1 is 4. So we have 5 1/3. Or we could write that as 16/3. Let's do one more. Evaluate the summation as I goes from 1 to 5 of 3. Now notice on this one, we don't have an I value in this expression. Sometimes it's helpful to force that I factor in there. And the only way we can do that and not change the expression is to write I to the 0 power. Because remember, anything to the 0 power is 1. So we'll have 3 times 1, which is still just 3. So I haven't changed that value. But I now have an I in my expression, so I can sub in my values of I. So this will be equal to 3 times, my first value of I is 1. So 1 to the 0 power plus 3 times, okay, my second value of I is 2, so 2 to the 0 power plus, and then 3 times my third value of I is 3, so 3 to the 0 plus 3 times 4 to the 0 plus 3 times 5 to the 0. 5 is my upper bound of my summation, or the ending value for I. So I can stop now. Let's just calculate these. Notice that any number to the 0 power is 1. So here I have 3 times 1, 3 times 1, 3 times 1, 3 times 1, 3 times 1. So this expression, the summation expression, is actually equal to 15.